In this section, you will learn how to create a static website, to build it using the Gitlab CI pipeline, and to deploy it using a cloud provider which has the possibility of hosting websites. And we'll be doing this using Gitlab CI. So let's get started. By now you're probably wondering what exactly is CI/CD, or continuous integration, continuous delivery, continuous deployment. So many terms, and how exactly does it affect us? Why should we care about this? Or what are these only buzzwords, or what do they mean? So let's first start with continuous integration and understand what continuous integration is. And actually, continuous integration is simply a practice. And when you're using continuous integration, you're integrating your code with other developers. Now, usually you're not the only one working on a project. And by using continuous integration, what it means is that every time you make a change to the code, that code is being integrated with the work that others did. And usually the way of integrating this is to see if the build is still running. So for example, you have a compile task, or you're somehow building the project, and if that task doesn't work anymore, then it means that the last one, probably the last one who has made a change to the project, did something that made the project not work anymore. So this is one step of continuous integration. The other step would be, of course, to see if everything still works if you test it. So let's say the project is still building properly, there are no errors. But if you're working on a website or any product, if the core functionality of that product isn't working anymore, we usually check such things in an automatic way by writing tests, and there are different levels of tests that we can write. But this is generally continuous integration. We try to integrate the work that we do all the time continuously. So there's no, we integrate our work once a week, and after 1 week, nothing works anymore. No, we constantly integrate every change that you do to a repository, or if the project is spanned over multiple repositories, every work, every change that is done there is integrated with the work of other developers, other people working on the same project as early as possible, so that we can get continuous feedback and to know what you have changed to the project is actually incompatible with what I've changed. So let's try to find a way and fix the project so that it works for everybody. Continuous delivery is after continuous integration. And usually you cannot do continuous delivery without doing continuous integration first. And the idea between continuous delivery is that in the previous step, you have created a package or something that you can deliver to production. And you're automatically installing this package on a staging system, on a pre-production or testing, or there are different names for it, but on a system that doesn't go live, doesn't affect real customers or whoever is using this software product. So the idea between continuous delivery is to build packages all the time and to install them in an environment. And only by using manual intervention, you can decide if a specific package, if a specific change set should go live. And usually you'll have this review system where somebody looks, oh, these are the changes that will go live. Is it okay from a business standpoint, and so on and so forth. And then we'll say, okay, this looks good. I'm gonna decide that this can go live. So it's only automatically installed in one system, and after a manual check, it can be installed on a production system as well. Now, continuous deployment in this case goes even further. And you can more or less say that every change to the project goes to the continuous integration stage, usually goes to a pre-production stage where you check again. And if there all the tests are good, then it means that this package that you now have can go to production as well. And if all the previous stages are successful, with continuous deployment, we'll actually push those changes to production automatically. So this review step, this manual intervention that somebody looks again at the system and says, oh, this is good, can go to production, totally disappears. And more or less every change that is made in the repository will go to production automatically. And in this case, you will have multiple deployments per day. So the advantages of continuous integrations are generally related to detecting errors and fixing problems or bugs as soon as possible. And when you're integrating multiple times a day, in which every change that you made to a repository is being integrated, it really reduces integration problems. Or if there are any integration problems, they are generally pretty small and can be easier to be dealt with than to avoid doing integration for a large period of time and then to do it much later. This also allows developers to work much faster, to create smaller changes to the code base, and to have more confidence that whatever they do, it will be easily detected by the continuous integration server, in this case GitLab. Because every time you commit a change, that change will be integrated with all other changes. There will be tests that will be executed, and hopefully any major bugs will be detected right there. Additionally, when doing continuous delivery and continuous deployment, it's more or less you make sure that everything you do is actually releasable. So you don't make any changes that are not designed to go live, or if you make any changes, you sort of will make sure that those changes are not accessible. Additionally, if you're doing smaller changes and they go to production quite often, is that it lowers the risk. Now, it doesn't mean that there's absolutely no risk. And this generally means that changes that introduce problems are easier to detect and are much easier to fix. And this is totally different from doing like very big releases where you're only deploying once a month or something like that, where you have a lot of changes and it's more or less, well, hopefully everything works, because if it doesn't work, then we have a problem. And actually, by deploying so frequently, you deliver more value. So you're building a product because you are building some features that somebody needs. And if you're delivering that features faster to the market, you have on one side a competitive advantage, but on the other side, you also get more feedback from your customers. So why make your customers wait for 1 month to give you feedback when they can give you feedback in a couple of days and then work on that feedback, or based on the bugs or problems they detected, you can make another iteration and make everything much faster. Now, in this lecture, I've tried to give you an overview of what continuous integration, continuous delivery, and continuous deployment really mean. But you will see in the next lectures and in this entire course, we'll be going and demonstrating exactly how this concept, how this practice of integrating code and practice of continuously delivering code can be implemented with Gitlab CI. And this is the most interesting part. And I'm sure that when you will be doing it on your own, you will have a much better understanding than watching these slides and saying, oh, GitLab, CI is when you're doing this and this, and CD is when you're doing this and this. You will have the chance of actually practicing this on your own. In the next lectures, we'll be using Node.js and NPM in order to build a simple static website. And in this lecture, I wanted to give you a short introduction to Node.js and NPM in case you're not familiar with these tools. Node.js is a JavaScript runtime environment that can execute JavaScript without actually opening a browser. We'll have a couple of tools that run inside the Node.js runtime environment. And this is why Node.js needs to be installed locally on your computer. And we'll also need Node.js when running the GitLab CI pipelines. More details on Node.js you'll find on nodejs.org. NPM is the Node Package Manager. You can see it like a repository of project and has knowledge of which requirements each project has. So each time when you install a tool, which depends on other tools and libraries, which of course depend on other tools and libraries and so on. So in order to figure out all the dependencies, you will need to have NPM installed, and NPM will do this work for you. And you can simply say NPM install this tool, and NPM will take care of that. Generally, installing Node.js and NPM on Windows, macOS, or Linux is quite easy, and you will not have a problem installing it. If you don't already have Node.js and npm installed on your computer, you will find attached as resources to these lectures a couple of tutorials which really show you how you can install it, and it's quite easy. And if you have any kind of issues installing Node.js, just let me know and I will do my best to help you. In this section, we'll start a completely new project. We want to build a simple static website, and for that we're going to use an open source tool called Gatsby. So I am at gatsbyjs.org, and I'm currently looking at the Getting Started tutorial. In order to use Gatsby, we first need to install it, and this is an npm dependency that we need to install. So let's copy this and open a terminal. The first step we should do is to check if node and npm are installed. That can be done by typing node -- version. The same goes for npm. As you can see, I have both of them installed and I can proceed. The next step would be to install Gatsby using the provided command. This will install the Gatsby CLI, and if you notice the -g flag, this will install this npm dependency globally on your computer. Gatsby has been now successfully installed, and let's continue with the tutorial and see what we need to do in order to create a new website. So to create a new website, we now have to use the Gatsby CLI command tool, and it's going to be Gatsby new, and this is how we'll name the website. So let's call our website static website. So I'm going to use Gatsby new static website. Now Gatsby has finished creating this project, and I will go inside the static-website folder that has been created by Gatsby. Now if I look inside here, I will see that some files has been generated, and for the moment it really doesn't matter so much, but now we have a new project. Now the first thing that we can do is to start the local development server, and that can be done by calling Gatsby develop. In just a few seconds, Gatsby will compile the project and start a local server, a local HTTP server, and that local HTTP server will be then available in our browser. So if we open this address, localhost on port 8000, then you will see our website that has been created. So this is how our website looks like now. It's not so bad for 2 commands, and we now have our own static website, and we'll continue working on it, but for the moment it looks quite okay. So let's take all the files that we now have and create a project on GitLab. So I'm going to click on new project and call this my static website. I'm going to keep this project and simply create it. Now, for the first time I create a project, it will be empty, and I can add new files using the GitLab interface, but the best way is to interact with Git. Now, as you can see, I already have a Git repository, and this Git repository actually has a history, and I'm quite happy with what I already have, so I don't have anything that I don't need here, so there's not a long list to read everything. So there's no need to recreate a new Git repository if I'm happy with that. So some of the steps I will need to skip. So the only thing that I'm still interested in is adding a remote. And then I'm going to push the changes to master. And as you can see, everything was successful. If I go back to my GitLab project and I do a refresh on this page, I'll notice that now it contains the files that I have committed. So you'll see here a bunch of files and even a quick description. So everything that Gatsby has generated, I now have available on GitLab. Now, so far we have installed Gatsby and generated a project, and we have managed to start the local development server. But what we actually have locally is a bit different from what we want to send in production. And generally, every tool has like a build step which is designed for production. So something that a piece of code needs to be compiled, or in this case, for this very simple website, there is some JavaScript that needs to be generated. Resources need to be like minified so that they don't take so much space. So a lot of the steps that you would not usually use when you're developing the application because they take a bit of time, you will have them in a build step, which will create a production ready build where everything is nice and clean. And Gatsby has a command for that. It's called build. So if I call Gatsby build, it will generate a new folder, and inside there will be like the website that I can deploy somewhere. So let's try it out. And now the build is ready, and you will see here that some of the last steps that were executed here is like building production JavaScript and CSS bundle. So where CSS is compressed in one file and everything is included there. The same goes for JavaScript. It's compiled and included in only one file. Static HTML pages have been generated and so on. So let's go ahead and inspect the build folder. And actually Gatsby doesn't call the build folder build. It calls it public, and it makes sense because all the files that are inside that folder are designed to be public. So let's switch to public and see what's inside. You have like an index HTML page, and you have some JavaScripts and everything that is needed in order to work with the website. And this is our artifact for this website. This is what we want to take from our build process and save it somewhere so that we can deploy it to a server, for example. And now we have tried this process locally. We now have this build. Then the idea would be to automate this step, to use Gitlab CI in order to execute this. You probably by now have heard about Docker. And in case you're wondering what Docker is and you do not know, then continue watching this lecture because I'll try to give you like a minimal introduction to Docker. Now, what I want to do in this lecture is to give you just enough information so that what we are doing this course with Gitlab CI makes sense. To begin with, Docker is a technology that is based on containers which allow virtualization. Think about that you need to install Node.js in order to run a piece of code, for example, a CLI tool. And you first have to download the proper version of Node.js, install it, and then execute the CLI tool that you are interested in. And this is only a very simple example. And what Docker does is to provide you with images, and you can build these images, and more or less you can start them on demand. So how does this generally look like is that you build an image where you say, I want to have Node.js installed on this image. And when you're using this image, you only have to start it, and you can already interact with Node.js because Node.js will be somehow installed. What Docker is good at is to make it easier to create and deploy and run applications when using containers. And what a container allows us to do is to package up an application with everything that it needs. So we have Node.js, but maybe Node.js is also dependent on other tools that we need to install as well. And you can more or less install all these dependencies that we need, configure them as we want to have, and sort of package them in a container. and say, well, if you want to run this tool, just take this container, start it, and you will have everything that you need. You can sort of view Docker like a virtual machine. So if you know what a virtual machine is like, you have an operating system that actually runs on another host, but it thinks it's its own operating system. Traditionally, so far, the approach was to install on the CI server all the tools and all the packages that we need. And this can be problematic because one simple example would be you installed Node.js on your continuous integration server in version X, and you use it for building tool A. But then you start working on tool B as well, and tool B would like to use a newer version of Node.js. But you cannot install 2 times the same utility on a computer. So this is why everything on the computer, everything on the CI server will have to work with the same version. And when using Docker, this is really not a problem because you can specify, oh, I'm building tool A with a legacy version of Node.js, but I'm using tool B with the absolutely newest version of Node.js or any other tool out there. This is just a simple example. So this is why it's very nice to use Docker and to understand what's actually the power of it. And we're going to use it in this course for different purposes. And this is generally the concept that is being used in GitLab CI. You're starting a CI runner and you're specifying to the CI runner, hey, CI runner, for the job that you're executing right now, make sure you use this specific image where I already have installed Node.js or something else. And this is why Docker is important and relevant in this scenario. And hopefully I've managed in this lecture to give you like a short introduction to what Docker is, but I'm sure it will make much more sense when you start using it when using GitLab CI or even locally on your computer. So let's continue with the rest of the course. In this lecture, we'll have a look on how you can use GitLab CI to build our project. So the exact step that we did on our own machine, we'll try now to replicate using GitLab CI pipelines. I have now opened the project in an IDE and I'm using Visual Studio Code, which is actually free to download and install. But if you want, you can still use the gitlab.com interface to edit files if that's easier for you. So it really doesn't make a difference. So let's try to create the pipeline that will build our project. And for that, you'll see here that we do not have a pipeline definition file. So we don't have a file that defines the pipeline. So let's go ahead and create one. And the first step would be to build the website. So let's define a step, build the website. And the script now. And we'll have a couple of steps we need to do. Now, first of all, this is a JavaScript project using npm. And this package.json file defines a set of dependencies which should be installed, otherwise the project will not work. So these dependencies are by default installed in this folder called node modules. And this isn't something that is being checked in with the repository. It wouldn't make sense, it would be a lot of files. So every time somebody needs to check out this repository and try it out to see how it works, would first need to install all the dependencies needed. And this is a step GitLab needs to do as well, because otherwise without these dependencies it will not be able to build the project. And in order to install dependencies, all we need to do is use npm install. Now the second tool that we are using is Gatsby for generating this website, for building, for taking care of these build tools, everything that's happening there. And of course, by default, Gatsby isn't installed as well, so we'll need to install Gatsby. And now finally, the step that we actually wanted to run is Gatsby build. Now let's go ahead and commit these changes and see how our pipeline looks like. And now the pipeline is running, and let's take a look on how the output looks like. Unfortunately, we do have a problem with our pipeline, and we have an error, and it is clear that the command that is generating this error is npm install. The error is pretty clear, command not found. So what does that mean? Well, by default, we are using a Docker image that is by default integrated with Gitlab CI. So what the runner is using is by default this image, Ruby in version 2.5. And apparently this image doesn't have Node and npm installed. And because you remember locally, we had to install Node and npm, and in order to use npm install and everything, we sort of need to do the same on GitLab. And the way we work with this is that we use Docker images. So the idea is not to take this image and manually start to install Node every time, because that would be a possibility as well, just to type in the commands in order to install Node. But ideally, we'll take a Docker image that already has Node installed. So a simple search on the internet for Docker image Node or whatever else you're looking for will most likely lead you to a website like this. Now I'm currently at Docker Hub, and this is like a repository with all the images that are being built. And anybody can publish these images. They are like official images from almost any software provider out there that's generating these images, so that everybody can use it, so that you do not have to worry about these additional steps. The name of this image is quite simple, is Node. And if we don't specify a version, it will always check out the latest version. But there's the possibility of specifying a specific version if that's needed. So let's go ahead and change our pipeline a bit. So in order to specify an image, all you have to do is go to your job and say image. And I'm gonna write here Node. Let's save commit and see how this pipeline looks like. You will see now that when the pipeline is starting, instead of pulling the Ruby image, it's pulling the Docker image Node. And this is exactly the image that we have specified here. Now you'll probably notice by now that Gitlab CI is not so fast, especially if you previously have worked with a continuous integration server like Jenkins. And the difference is how GitLab is working, and especially the usage of Docker, and that everything that is being generated here is thrown away after this has been executed. So as soon as the job is done, all this information is no longer available. And if you have any experience with Jenkins, and if you don't worry. In Jenkins, you have something like workspaces, and every time a job is running, it has its workspace and don't have to download all these dependencies over and over again. And later in the course, we'll look on how we can make our jobs a bit faster, but generally you don't have to worry now in the beginning why your jobs take a bit to execute. Now our job was successful, and the static website has been generated. Unfortunately, as I have previously explained, once this job is done, you have nothing to see. So the execution is completed, but the website that we have built isn't available. So what we need to do next in order to use the artifact that has been built, so the artifact in this case is the website that we are building, is to specify where is the artifact so that we can save and inspect it. For that, we're going to use artifacts. And the path that we are interested in is inside the folder public. So I'm going to simply say public, but you can also specify it like // and then you're referring to the current directory we're inside. This is a bit more specific than just saying public. Now the job execution is done. You'll see that the artifacts have been generated and now uploaded. And here on the right side, you will be able to either download them to inspect them on your own computer, or for specific files, you can view them directly in the browser. So I'm going to click here on Browse. And you'll see the public folder that we have selected. And if I go inside it, you will see all the files and folders that are related to the website. And you'll not see anything like node modules or something like that. It's only the static website that we're interested in. This is the production build that we want to deploy. So the rest of the repository, what we have inside, is something that we are not interested in deploying. And will be a lot of files that will be totally needless because they are like private files. These are public files that have been generated. So this is how we have migrated this build job from our own computer to Gitlab CI and have managed to build this artifact. Just to recap, in order to use npm and node, we first have to use a Docker image that already provides node, that has node already installed. And after that, the steps that are needed are pretty simple and are inside the documentation. We have to install all the dependencies, and then we're using Gatsby CLI to generate the build that now this Gatsby website has. And the artifact will be generated in the public folder, and we are saving it, instructing GitLab. This is the artifact. We want to save it for later stages. So make sure you keep it and do not throw it away after this job has finished. In this lecture, we'll have a look at adding a test stage to our pipeline in order to test a bit what we have previously built to make sure that what we have is actually what we want to have. And the first question generally is that what makes GitLab CI jobs fail? Why is the pipeline all of a sudden failed and doesn't continue with the next steps? So it goes more or less like this. Every time a command is executed, it will return something. And by convention, it will return 0 on success, and it will return an integer in the range of 1 to 255 on error. So every time GitLab CI gets a status that is not 0, which means success, it means that something failed. And the command can return a status code in that direction if it hasn't been properly called, if it's missing parameters, or if a certain assertion isn't the way it should have been. So this is why we can rely on the status code of the commands in order to write small tests directly from the script without relying on any other third-party frameworks. Now, ideally, you are building something and you are running unit test, you are running everything that is needed in terms of testing to make sure that what you have built is something that you want to deploy later. But in this simple example, we're going to look on very, very basic tests just to demonstrate how this stage can look like and what we can do. And let's imagine, for example, we want to test if the files have been properly generated. And one idea would be to test the index.html file to see if it contains a specific string. I'm now inside the public folder, and I'll be using grep in order to search for a specific string inside a file. So let's search, for example, for Gatsby. And the file that we are searching into is index.html. And you will see here that it has returned the entire string where Gatsby is being found. You will see it even marked here. So this was a success. Now, in case you're unsure about the status code or what has been returned by grep, especially if you're using grep in a quiet mode, which doesn't give you any output, you're a bit unsure, does this work or not? So what we can do for debugging purposes and to understand how exactly return codes work like is to simply echo, and using a $sign and a question mark, you will get the last return code. So in this case is 0. So let's search for something that definitely doesn't exist. You'll notice here that my terminal is a bit intelligent and directly gives me the return code here. But in case yours isn't that, you will see that this has returned 1. And this is a simple command that we can use inside GitLab in order to make our build fail if something doesn't work. So let's go ahead and add this additional job. I'm going to call it test artifact. And the script will be quite simple. I'm going to grep for Gatsby inside the index.html file inside the public folder. Let's go ahead and define the stages that we have. We'll have the build stage and we'll have the test stage. The way you name your stages and the way you name your builds is totally up to you. You can simply call this build and the stage will be build. So there's absolutely no problem. They don't have to be different. You just need to specify which job belongs to which stage. And this will be stage test. I think it's generally a good idea to test whatever you're doing to make sure it fails as well. So I'm gonna add here something that will succeed and something that will fail. Just to have assertions, just to have tests that actually work and just don't give us the feeling that something is working but actually doesn't work. So always test what you're doing. Just don't assume that something will automatically work just because the command looks right. Okay, I think we're good. Let's commit this and see how the pipeline looks like. Now, if you look at our pipeline, you will see that we now have 2 stages. And we already know that the first stage will be successful. So what we're interested in is seeing the second part of the stage, the test stage. So we'll wait a bit for that. The first stage is completed and now the test has started. So let's take a look at it. You will notice that in this job, because we haven't specified an image, it will default to the image that the GitLab runner is providing, in this case, Ruby. And we'll look a bit later on how we can replace that as well with a different image. So this is the output of the test. The test has been successful and the first command succeeded, and the second one, we have now the exit code 1. So everything looks good at this moment. And in this way, we have now managed to add a test stage that proves that what we have previously built is, at least at a very minimalistic level, the right thing. It contains what we expect it to contain. Now let's continue with our testing strategy and make some optimizations. We'll now remove this command because we don't want our tests to fail. We actually want them to succeed. And we'll add a quiet flag -q in order not to have this large output of data in our logs from GitLab, which is definitely not interesting for us. I have previously mentioned that the test artifact now is using the previous default image from Docker. And we can leave it that way, or we can specify our own image. There's a Linux distribution out there that is very, very minimal. It's only 5 megabytes in size and it's quite fast. It's called Alpine. And let's give it a try for this job to see if the job succeeds using this much smaller image. Now, in order to test this artifact, we do not need Node installed or anything else. So for that reason, we can simply try out this image and see if at least this utility grep is installed, because this is the only thing that we actually need. Additionally, let's go ahead and add another job. Gatsby offers us the possibility of starting a server, and when you're starting that server, we can use HTTP in order to access the website and to see how it looks like. So this can look like the following. So let's call this test website. And we'll add this to the stage test as well. And you will later see what this has for an effect. And now let's see what we need in order to be able to start this. So we're going to use Gatsby serve. And this will start the server using the production build that we have previously generated. Now, in order for Gatsby to run, we still need a couple of steps. So we still need npm install, and we still need to install the Gatsby CLI, otherwise this will not work. And additionally, we need the following. We want to use curl, and this is used for fetching resources. And the resource that we are actually fetching is the local website. So Gatsby serve will start a server. It will be available on localhost, usually in port 9000. So let's see how that can look like. So curl will basically download the website, will download the contents of this website. And we can use what we have previously used. We can simply grep for this string. And when using commands, we can use the pipe operator. So the output from downloading the website will be piped, so will be given as an input for the grep command. So we do not have to specify the file that we want to search for a string. So this is the download. The website is the input, and it's giving it to grep. And if grep fails, then this will fail as well. There's one more thing that I need to do. I need to specify the image. We still need Node for this. And after this, let's give it a try and see how it looks like. One of the first things that you will notice if you're now looking at this new pipeline is that we have two jobs running in parallel. And this is because we have created the test artifact job and the test website job, and we have assigned them to the same stage named test. And when we do that, we actually are telling GitLab that it should run these jobs in parallel. Now, in this specific case, running the job in parallel will probably not make the job run faster because it will have the overhead of downloading the Docker image. But there are scenarios when it definitely does make sense to run different tests in parallel, because if their execution is long enough and you run different tests in parallel, then altogether they will be much faster and your pipeline as a whole will be much faster. If you're interested in sort of optimizing your process, then this is a good idea. I have to say that not every job can be parallelized, and especially if there are dependencies between the jobs, you cannot do it. So for example, we cannot run the build step and the test step in parallel, because in order to test the artifact, we first have to build the artifact. So if there are any dependencies between the jobs, then we cannot do that. But as we have it in this scenario, we are building the website and then have the artifact. And then we're doing something with the artifact. The one job is simply testing its output, testing some files, and the other one is starting a server and doing something. Then we have no problem with that. That is definitely possible. And you will see now that GitLab is executing both jobs in the test stage in parallel. And the first one is actually done. And you will see that it was quite fast. So using the Alpine image was definitely worth it, because we have executed the entire job in only 20 seconds. And that is absolutely amazing. Now, if you're looking at the test website job, you will see, or you probably figure out, that we have done something kind of weird. So now we have executed Gatsby serve, and it's saying that the website is running at a specific address that we actually expect it to. But it seems that the next command is not being executed. And this is because Gatsby serve sort of blocks the entire terminal with this execution. So it will not allow for the next command to start, and the process is sort of still running. So it will not give back the possibility for the rest of the job to continue. And this is not exactly what you wanted to do. And if we leave it in this stage, it will more or less run forever. Well, not actually forever. If you look here on the right side, you will see that you have the duration of the job. So how many seconds have passed since the job started? I'm at 3 minutes, 4 minutes almost. And there's also the information regarding the timeout. Now the timeout means if this job is not responding after 1 hour, GitLab will automatically kill it. So if the entire job takes more than 1 hour, there's something wrong with it generally. It shouldn't take that long, and especially in our case, it should only take a few minutes. And if you leave it in this stage, as I've said, it will run forever, or in this case, it will run to the timeout that is configured here at 1 hour. And after 1 hour, GitLab will fail this job because it has run into this timeout. Now, we don't have to wait 1 hour to fix our mistake in this case. We can click here on cancel, and we can just terminate the job. So what we need here in order to sort of release the terminal is to use the end sign, the ampersand sign. And what will this do is sort of run this process in the background. So it will execute this, the server will continue to run, and it will release it for the next command. Additionally, what we want to do, because the server takes like a few seconds to start, we want to include a small pause in our execution. And just to give the next command a chance and to give the Gatsby server a chance to start, we're gonna say here sleep. And we are gonna indicate a number of seconds. I think 3 seconds should be more than enough. And this is not the smartest way to do it, because no matter how fast the server starts, we'll always wait 3 seconds. But for the simple example, is definitely more than enough just to exemplify how we can include a small sleep inside the script, but we'll deal with that a bit later. Okay, so let's commit this and see how it looks like. Now, there's an important thing I want you to notice when you're going to view all the pipelines that are currently running. And this is available in CI/CD pipelines. And you will see here that we still have the previous pipeline running from the previous commit. And because we have pushed another change, another pipeline was started. So we now have 2 pipelines running in parallel. So I just wanted for you to be aware that there's the possibility that pipelines run in parallel. So they will not be automatically canceled or something like that when the new pipeline starts. You will have pipelines running in parallel. And especially as this previous pipeline, we don't need it anymore. We can cancel the job, or we can actually cancel the entire pipeline. It really depends on how you want to do it. I'm gonna click here, stop the pipeline. And now we'll see here that the pipeline has been cancelled. You can additionally cancel jobs. So every time you click on a job, and you will see here this button. If I click on it, you can cancel individual stages. So if you're like constantly working on your pipeline and trying to optimize it, and at the same time you want to sort of save resources, or you have the impression that the pipeline altogether is running a bit slow, you can definitely cancel jobs that make no sense in continuing to run. Now let's take a look at what our test website stage is doing. And you will see that this is still failing, but at least what we have done here is worked. So we are serving the website, and after this we are waiting a few seconds. And you will see that in parallel, you're still getting outputs from the Gatsby serve command. So it's saying here, Gatsby serve running at this address. Now the process in figuring out what has happened here is relatively the same. Generally, what you want to do is to identify from where this error is coming from, and obviously it's coming from this command. And we're getting here this error failed writing body. And the idea would be to search for this specific string and to find online help on why this is happening. And for example, a quick search leads to Stack Overflow with somebody having a similar problem. You will see here that's using curl and this passing this information to grep. And apparently it says that this happens when a program, for example grep, closes the read pipe before the previous program is finished writing the whole page. And as a solution is using tag, and is saying that tag is a simple Unix problem that reads the entire input page and reverses the line order. For that reason you have to run it twice. So let's try this and see if this solves our problem. So I'm gonna add here tag, another tag. And you will see now that the test job stage has succeeded and that the fix that we have found online seems to be working. And always, as I have said with tests, change the string here, make sure that it fails, make sure that everything works properly before just leaving it in production and relying on things where you're not sure. So let's review again what we have learned in this lecture. We have added a new job, and because two jobs now are in the stage test, these tests are being executed in parallel. Now in this first one, test artifact, we have used this Docker image Alpine, which is a very, very small minimalistic image, but it's just enough for us to be able to run this grep command. And as you have seen, it executes very, very fast. So it's like 20 seconds to download the image, start the image, and run the script that we have. And in this second job that is running in parallel, we are using the node image. We have then the script you have to install npm in order to use Gatsby, and we're using Gatsby to start the server. We are using this AND operator, which makes this command run in the background, and it's releasing the terminal so that the next commands can be executed. And we have the sleep. We are waiting a few seconds, give the server a chance to start. And after that with curl, and with curl we are calling this address and then waiting for the entire response to be written, the tag command that we have used as a solution to the error that we were getting. And then with grep, we are searching for the string. Now we have a static website, and ideally we want to deploy it somewhere. And for the next example, we'll be using Surge in order to deploy our website. Now you're wondering, what is Surge? Surge is a cloud platform for serverless deployment. And in case you haven't heard the name serverless before, it more or less means that you are not taking care of the server where your application is running. So you are just saying, host this for me, but you have no control on exactly how is this being hosted. You don't have to worry about software or anything like that. And we're using it because it is really easy to use and configure. And it offers us a very simple deployment process that we will eventually implement in Gitlab CI. And it is ideal for small static websites just as ours. So in order to get started, we have to do a couple of steps. We already have Node installed, and that is a requirement. And additionally, we have to install Surge as well using npm. So I'm going to copy this command and open a terminal and run it. So npm install -- global surge. Okay, this only took a few seconds to install. And now let's type in Surge. So I will type my email and my password. And this is how we create an account with Surge. And this is the same procedure you use for login as well. Now, because I'm inside a public folder, which I recommend you do, Surge is already detecting this path and linking it to the public folder. So I don't have to make any changes here. I'm just gonna hit enter. For the domain name, this is something that Surge generates automatically. And I think it's definitely fine to just leave for now whatever domain Surge has selected for you. You will be able to change that later. And now Surge is starting to deploy the website. And it says success. It has published the entire website to this address. So believe it or not, in just a few seconds, we have managed to deploy our application using Surge somewhere in the cloud. And now we have this address where we can call it. In this lecture, we'll have a look on how we can manage secrets when using GitLab. You generally do not want to keep any credentials, and generally even usernames or passwords or tokens, anything that is sensitive, you do not want to commit that in your pipelines or in any files or something like that. So anything that goes inside Git shouldn't contain tokens, passwords, secrets, or something like that. And Gitlab CI offers us a convenient way in order to store such secrets. Now, the goal is to be able to use Gitlab CI in order to deploy the website to Surge. And as you have seen, we have this interactive interface where you're using our email and password. And this is something that's, of course, not available in GitLab because you cannot interact with this tool and start typing in things. And generally, you do not want to use username and passwords in order to do deployments. And such tools offer the possibility of using tokens in order to log in. So instead of using your username and password, you supply this token, and you can even later revoke the token if for whatever reason you think it has been compromised without actually changing your username and password and without exposing them in this case. So let's go first to Surge and generate a token. I still have my CLI opened. And what I need to do is to type in Surge token. And I'm sort of still logged in with Surge, and Surge has then generated this token for me. Let's go to gitlab.com and see where we can manage these secrets. From the sidebar on your project, you should be able to see right here at the bottom settings. And if you hover over it, just go to CI/CD. And right here in the middle, you will see environment variables. And environment variables, as it says here, are applied to environments when using the runner. So we can define here variables, and these variables will be injected by GitLab and will be available in the runner. So let's expand this and add our secrets here. So we're going to create two different variables. We're going to use a variable called Surge login, and this will be our account. So your email address that you have used to register for Surge. And the second environment variable that we'll create is Surge token. So Surge_token. And this is the token that you have been given in the CLI. So let's go ahead and save these variables. Once you have saved this information, you will no longer see it, but just in case you want to check if everything is still okay, you can click here on Reveal Values, and you will see the original values. So that's about it. This is how you can save and manage secrets in GitLab by using environment variables. And as I said, these environment variables will be later available when you're running the jobs. The next logical step would be to deploy the website, and this time using Gitlab CI and not from our own computers. So for that, I'm gonna define a new stage. I'm gonna call this deploy. Deploy to Surge. I'm gonna call the job, but feel free to name it as you want. I'm going to still use the node image, and now I have quite a few jobs that use the same image. So what I can do right now is to take this out of here and put it right here on top, so that by default node will be used for all the jobs, and all the other jobs that have node, I can simply remove it, and the other jobs will have it by default. So let's see how our script will look like. Now this time we will not be working with Gatsby anymore, and actually only need the CLI tool from Surge. So for that reason, we don't have to do npm install, we don't have to install Gatsby CLI, we only need to install Surge sh. So the command to do that is npm install -- global Surge, and that will be just enough to install Surge. Now we have installed Surge, so we can call Surge. And we'll need to specify our project, -- project. And this needs to be the path to our project. So I'm going to say /public, because we are already inside the folder that contains the public folder, and we only need to reference it. And now we need to specify a domain as well. So -- domain. And it needs to be something like something.surge.sh. And this is something that you need to decide for yourself, and of course first to make sure that this isn't taken anywhere, and at the same time to make sure that this is unique enough so that nobody else has taken it already, otherwise of course you will not be able to register it. I have used this domain name generator just to find something unique or a bit more unusual, and I'll be using InstaZone for my domain name. But this is just because I don't have any better idea what to name my domain like. But feel free to type in whatever you feel like. So my domain will be InstaZone. We don't need to specify any tokens because we already have them as environment variables. So Surge will look for the variables that we have defined and will automatically use them to authenticate ourselves. So that's about it. Let's save it and give it a go. There's one more thing we need to do. Now we have defined a stage called deploy, but we haven't assigned the job deploy to Surge to that one. So by default, if you don't specify a stage for your job, then it will automatically go to the test stage. And this is something that we don't want at this step. We first want to run our tests and then deploy. So let's do that small change as well. So stage. And now our pipeline has 3 stages: the build stage, the test stage, which runs in parallel, and only when both jobs with test have been executed and are successful will the deploy stage be executed. So if any of the stages here fail, then the deploy will not be executed. So it seems now that the pipeline has succeeded, and let's look at the final stage to see how the logs look like. And you will see here there's nothing very special. We have installed Surge, and with this command surge -- project, we're specifying the project, and then with -- domain we are specifying the domain, and we are logging in, and yes, success, published to InstaZone that surge.sh, and of course in your case it will be a different domain name. So let's open this in the browser and see how it looks like. So this is the website automatically being published using surge sh, and all done automatically through Gitlab CI. Looking back again at our configuration and at the command that we have executed, there's still a question regarding how exactly does Surge know to use the tokens and the username that we have provided as environment variables. Because if you look at the command, you will only see that we instructed the location of the project and the name of the domain. But After that, apparently Surge knew what to deploy, which is the account, and had the right permission to do it. So many CLI tools rely on environment variables in order to reduce the configuration that you have to put in when using the CLI. The reason for that is authentication information, for example, will need to be placed in each and every command, and that can make the command longer and not necessarily for a good reason. So if you look at this command, you can see it's pretty simple. Now, if we had to add additional parameters with a username and a token, it will make the command longer. So in this case, Surge knows how to look for the username and the token. But this doesn't happen randomly, so Surge will not start looking through all the environment variables. It will look for a specific environment variable for that specific value. And if that information is present, it will use it. Otherwise, if Surge or other CLI tool will not find the predefined environment variable that it's looking for, then it will either use information from the CLI or it will say, hey, you haven't provided me any authentication information or any other information that maybe is required. As with many CLI tools, the only way to know how exactly to name the environment variables is to look at the documentation. In the case of Surge, this is a bit hidden and it's actually mixed up with other documentation. But you can see here that this is documented in the sense that it says you can create one environment variable called Surge_login and set it to the email address you want to use Surge, and again the Surge token. What's important to notice is that you need to name the environment variable exactly as Surge expects it. So for example, if you give here a different name for the login or a different name for the token, or you just say token, then Surge will not know that token is meant for Surge. So you have to give the exact name as in the documentation. So the main takeaway here is that many CLI tools will rely on environment variables to get some information. And if you specify those environment variables as the CLI tool expects them, then it will automatically look for them and use them. And this is a very good way on how you can reduce the length of your configuration, the length of the command that you are using in your pipeline.